Good shout in this question is to draw a sketch of what's going on. So we've got an origin, and then we've got this vector A, which I've roughly put at -3, 4. We can now write in as a coordinate. And then B is 1, 2. We're then told that point C has a position vector P1 and ABC is a straight line. So if I draw a straight line going from A and B, then C is somewhere along it, and maybe it is roughly here. Okay, I'm going to go through A and B one particular way, which I think is the most effective way, and then I'll talk about some alternatives. But what I've essentially done is turn this into a coordinate geometry problem, because now I can find the equation of the straight line that goes through A and B, because I'm given 2 points, and from that I can work out the missing value P. So I'm going to do it that way. Right, first of all, it must be that MAB is equal, I can use y2 minus y1, so I'll go with 2 minus 4 over x2 minus x1, 1 minus minus 3. That's going to become minus 2 over 4, or minus a half. So from that, I've got that the line AB is going to be y minus y1 equals m x minus x1. So I can substitute in either A or B. I'm going to go with B just because the numbers are all positive there. So y minus 2 is equal to minus a half x minus 1. This is brilliant. This is the equation of my line ABC, in fact. So now I'm going to let x equal p and y equal 1, and I can substitute these in. 1 minus 2 is equal to minus a half p minus 1. That's going to give me minus 1 is equal to minus a half p minus 1. I'm now going to multiply through by minus 2, or equivalently divide through by minus a half. That will give me 2 is equal to p minus 1. So finally, p is equal to 3. Okay, not too bad. We're then told that point D has position vector Q1 and angle ABD is equal to 90 degrees. So ABD is going to be, I'm going to get a line like this where there is a 90-degree angle, and maybe D is going to be here, for example. I'm going to draw in, there we go, we've made a triangle now, ABD. So again, I'm going to write it down as Q1. I've put it here because I can see that the y coordinate is quite small, so it's got to be below B but above the origin. Right, now this time I could work out the equation of the perpendicular line using the same kind of method. So MdB is actually going to equal 2 because it's a negative reciprocal of minus a half. So because we've done all this work in part A, we're nearly there, because I've got the gradient of a line that goes through B and D. It's going to go through B, so I can now again write down y minus y1 as mx minus x1. It's just, instead of minus a half, I'll have 2. Okay, now I'm going to let x equal q and y equals 1. So I'm going to get minus 1 is equal to 2q minus 1 minus a half is equal to q minus 1. And so q is going to equal a half. Not an easy question, I think. I think turning it into a coordinate geometry problem is the best thing to do. We are there. That's quite a lot for these 5 marks. I'm just quickly going to talk about how you could do this question differently. And I'm just going to sort of write above, I think. So I'll talk through it. A second way you could do part A would be that you don't actually need the equation of a line. You could you've got the gradient of AB, you could actually work out the gradient of BC in terms of P, and then set them equal. And I'll just start you off with this. So it'll be minus a half equals, and then maybe we do 2 minus 1 over 1 minus P. If you kind of do the working from there, then you'll get that P is equal to 3. So it's arguably a little bit quicker actually. However, me doing the work and getting the equation of this line had made it so that B was easier. But that is there if you prefer. For B, there is another way you can do this question as well. I personally think it's more complicated. You could, remember we've got a right angle and a triangle here. You could work out the lengths of AB, BD, and DA, and then use Pythagoras' theorem to work out, to basically equate some of the sides and then work out Q. Another way that I saw in the mark scheme, which is essentially the same thing, was to write AB down as a vector, and BD down as a vector, and AD down as a vector, and then use Pythagoras' theorem directly from that, showing it's like finding the lengths of the vectors, which is essentially the same thing. It's just using vector notation. I personally think that these 2 ways that I've done are just as good, if not better. So anyway, I hope you're happy with this question.